squared cannot come from two different sides.
Uh-huh.
And it also cannot increase without bound. That limit.
Okay. All right. Okay. All right. That's fine. Okay. The bottom line is that from the left and the right, it should be coming to the same number. Should be coming to the same number. And then the third criteria is that if the limit exists, then it's got to be equal to the function value. Okay? All right, so this is math. Then what's another way of explaining things? Ah! Do you want a hug? I got to ask you now. Do you want a hug? Pictures right there.
Oh.
Too late now.
I thought I didn't get the right answer. Someone else did.
No, come on, it tells you right there. Pictorially. Yeah.
Maybe we can do air hugs.
Yeah, really.
Like our high fives. We can do
High fives. Okay, so right here. So here's a continuous function. So Felix, are all three conditions satisfied on this function? What are the three conditions, Felix? Does this one have a hole? What do you mean? Pictures right there. No. Okay, so that condition satisfied. What's the next one? The limit exists. Does the limit exist? Yeah, if you go on this graph from the left or the right of C, does it approach the same number? In this example, what number is it? 2? Oh my God. Guys smoke on the weekend, Henry? Ruins your eyes, okay? That stuff ruins your eyes, you know, and your brain cells, and your lungs. Okay? What about the third condition? Does it satisfy the third condition? Sorry? The limit exists, and the limit is equal to the value of the function. So what's the value of the function at C? 2, and the limit is 2. So this is a continuous function. Nice. Next one. S, are you on the phone? You're not participating. S. S knows who it is. Okay, this one. This one's not continuous. Okay, so from a simple English description, you cannot draw this line without lifting your pen up, because you're going to jump over the hole, right? So, no, you're going to jump. No, you're going to. Oh, you're a swimmer, so you don't know how to jump. Ha.
I can dive.
You can dive, but you cannot jump.
I can dive real well. Dive. When I get on blocks, I can dive.
Yes.
I can get over the hole. There's still a limit.
That's right. Exactly right. So what's the limit in this case here?
I can go straight.
Yes, good job. So even though there's a hole, there's a limit, and therefore this function is not continuous because property 1 is not satisfied. Number 1 out of the 3 is not satisfied. Is everybody with me on this? Okay. Jonathan, you taking notes? Why am I picking on you? Because you're just sitting there, man. If you are pretending like S is texting or something like that, then I won't even know. Except S is not even pretending. She's actually doing it. So this is not continuous because it doesn't satisfy the second property. And so, Felix, what was the second property? That's right. Does this one do that? It doesn't. So coming from the left, what number is it going towards? Coming from the left, what number is it going towards? 3. Nice. And coming from the right? 1. Nice. Good job. Good job. You guys okay on that? All right. So the second property is not satisfied here. Is everybody with me on this? And then the last one. So this is an entirely different function, but it's not continuous because it doesn't satisfy the third property. And Sujal, Zara, Sujal, what's the third property? That's property 2. Property 3. Sorry? That's right. The limit is not equal to f of c. Does everybody see that? What's the limit equal to in this case as x approaches c? Approximately, okay? Not. Nice, good job. A little bit more than 7, 7.5. And what's f sub c? 4. Is everybody there? Everybody get this? Yeah, so this one, like Tatiana is saying that the limit is not equal to the function value. So let's go let me snip this guy. No zooming works in here. So you know that if you go on the graph this way, you're approaching this number here. Looks like it's about 7.5. If you go the other way from the other side, you're approaching 7.5 as well. But the function value is 4 right there. It tells you right there. That's f sub c. So it's 4. These two are not the same. Right? That's property 3. That's why it's not a continuous function. Is everybody with me on that? Okay. Wow, what's with the popping? Oh, Cindy. What's with that stuff? Is it Heather or is it you? I don't know. It's coming. It's coming from that. I told you, man, the beats have really messed up my hearing. Okay, I kind of hear it from all over. Okay, so there are two kinds of discontinuities, ones that are removable and ones that are not. And what I want you to do is I want you to turn page 71, read or take a look at example of figure 1.26, and then study example 1 on page 71. Okay, removable or not removable. So taking a look at example, and this is the same example as 1.1b on page 71. So it says discuss the continuity. So in other words, what it's saying is this function continuous? If it is not continuous, does it have a removable discontinuity? In other words, can you remove the discontinuity? Okay. So let's take a look at what this is all about then. So first of all, see that this function turns out to be a straight line, but it's got a hole in it.